Geometric sequences are a little bit different from arithmetic sequences. Instead of adding or subtracting to get the next number in the sequence, you're multiplying or dividing. So if I look at the sequence 10.2.4.08.016, you figure out real quickly that it's not arithmetic, because if it were arithmetic and you subtract the second term minus the first term, you don't get the third term by adding 8. So there must be something else going on. So what we're going to do is we're going to look for something called the common ratio. The common ratio works similarly to the common difference. It's going to be the second term divided by the first term. So in this particular problem, if I want to find out what I'm multiplying by, I take the second term divided by the first term, and I find out that I'm multiplying each time by 1/5 or 0.20. I don't really care if you tell me the fraction or the decimal. So if you're wondering, did it work? If you do 2 times 0.20, do you get 0.4? And the answer is yes, you do. So in example 1, let's determine the common ratio and then find the next 3 terms in each sequence. So again, to find the common ratio, all you have to do is take the second term and divide it by the first, and that's going to tell you what you're multiplying by. So 4.2 divided by 21 is 0.2. And then the next 3 terms, you would start with the last one you have, which is 0.84 times 0.2 is 0.168 times 0.2 is 0.0336 times 0.2 is 0.00672. Now you know they couldn't just stay that easy. So in the next problem, we want to find the next 3 terms in the common ratio of 2t minus 10, negative 4t plus 20, 8t minus 40, ... Remember, the common ratio is the second term divided by the first term. Well, if you divide those, this is what I want you to know. Now, some of you may actually be able to just look at it and figure out the answer. But algebraically, you would factor out a negative 4 from the numerator, and you would factor out a 2 from the denominator. And then these are common terms. They get canceled, and you're left with negative 4 over 2, which is negative 2. Or you could have just looked and noticed that you have to multiply by negative 2 to change the first term in each term of the sequence, and then you have to multiply by negative 2 to get to the next term. So if the common ratio is negative 2, then the next term in the sequence is going to be negative 16t plus 80. The next one's going to be 32t minus 160, and the next one's going to be negative 64t plus 320. In C, 8, negative 4, 2, the common ratio, second term divided by first term, it's going to be negative 1/2, or negative 0.5 if that helps. So 2 times negative 0.5 is negative 1, times negative 0.5 is negative 0.5, or positive 0.5, and then times negative 0.5 is negative 0.25. In D, the sequence is 3, 6x, 12x squared, ... So the common ratio is 6x over 3, which is 2x. So if I multiply each consecutive term by 2x, the next term in the sequence is going to be 24x to the third. The next one's going to be 48x to the fourth. And the next one's going to be 96x to the fifth. Just like there was an nth term of an arithmetic sequence, there is a formula for finding the nth term of a geometric sequence. Because if you want to find the 100th term in a sequence, you don't want to write 100 numbers down. The formula is a sub n is equal to a sub 1 times r to the n minus 1. So So let's use this formula. In example 2a, find the approximation for the 12th term in the sequence negative 24, 26.4, negative 29.4, 04, ... So I know I'm looking for the 12th term. I need to know the first term. I need to know the common ratio. And then we're going to raise that to the n minus 1, where n is 12. The common ratio is the second term divided by the first term, which is negative 1.1. And then I'm just going to shove this in my calculator. Before you put in your calculator, I would probably change 12 minus 1 to 11. So negative 24 times negative 1.1 raised to the 11th is approximately 68 maybe we'll do 47. Let's try this again. Find the approximation for the 10th term in the sequence 6, 18, 54, ... The 10th term is equal to the first term times the common ratio is 3 raised to the 10 minus 1 power. So I'm going to type into my calculator 6 times 3 raised to the 9th, and it's going to be 118,098. Just like we call the numbers between two non-consecutive terms of an arithmetic sequence the arithmetic means, we call the terms between any two non-consecutive terms of a geometric sequence the geometric means. This is going to work very similarly to the way that it did for arithmetic sequences. So if I want to write a sequence that has two geometric means between 128 and 54, it means there's two numbers I'm going to find, and the first number is 128 and the last number is 54. What I don't know is the common ratio. So I'm going to use my nth term formula to find r. So I must know everything else. So I know the nth term. I know the first term. I don't know r. But I do know how many terms in the sequence there are. There are 3. So how do I solve this for r? Well, first you're going to divide 54 by 128. And it wasn't a pretty number, so if you write it as a fraction, which I think is going to help, it reduces to 27 over 64. And that's going to equal r to the first power. Nope, not first power. R to the third, because that should be a 1. And then in order to solve for r, you'd have to cube root both sides. A reminder about taking radicals of fractions. You take the cube root of the numerator, and you take the cube root of the denominator. So the cube root of 27 is 3, and the cube root of 64 is 4. And so r is 3/4. So now you come back up here, and 128 times 3/4 is going to be 96, times 3/4 is going to be 72, and in case you want to check to see if you got it right or not, if you multiply again by 3/4, you better get 54, which I do. Let's do this again. Write a sequence that has 3 geometric means between 3 and 243. All right, so that means there are 3 numbers in between. The first number's 3 and the last one's 243. That means there are 5 numbers in the sequence. So the nth term, which is the last one, 243, is going to equal the first term times the common ratio to the n minus 1 power. First, we're going to divide by 3, so 243 divided by 3 is 81. And that's going to equal r to the 4th. So in order to finish, I need to take the 4th root of 81, and the 4th root of 81 is 3. That means we're going to multiply by 3 to get each consecutive term. So 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. The next thing we're going to talk about is a finite geometric series. Series occur when you add all the numbers in a sequence. Now, the reason we define this as a sum of a finite geometric series is because in a future section, we're going to talk about infinite geometric series. So for right now, we're going to tell you how many numbers we're going to add together. Now the formula that's on the notes, S sub n is equal to a sub 1 minus a sub 1 r to the n over 1 minus r, it looks a little complicated, and we can simplify its look, but it's still the same equation. If we rewrite it here in purple, so it's going to be the first term times the common ratio to the nth power minus 1 over the common ratio minus 1. And this formula, we're less likely to make a mistake. So I really like this formula better. So in example 4a, we're going to find the sum of the first 8 terms of the geometric series 14 minus 70 plus 350 minus 1750 plus dot dot dot. So the sum of the first 8 terms is going to be the first term times, we need to find the common ratio, so the common ratio is the second term minus the first term, divided by the first term, which is negative 7/4, or negative 1.75, you might like better. So I'll just do that, negative 1.75. We're going to raise it to the nth power, minus 1, over r minus 1. When I go plug this into my calculator, I'm going to add an extra set of parentheses around these. If you want to put the whole thing into your calculator, you can. However, I prefer to first put in parentheses negative 1.75 to the 8th minus 1, close the parentheses, and then divide by parentheses negative 1.75 minus 1, and that'll give me what's in the parentheses, and then I like to multiply that by 14, and I'm going to find out it's approximately 452.9. In B, find the sum of the first 8 terms of the geometric series 1000 plus 500 plus 250 plus 125 plus dot dot dot. So the sum of the first 8 terms is going to be the first term times the common ratio, which is clearly 1/2 or 0.5 to the nth power minus 1 over r minus 1. I'm going to evaluate what's in the parentheses first by putting extra sets of parentheses around these when I calculate it. So parentheses, 0.5 raised to the 8th, minus 1. Close the parentheses, divided by 0.5 minus 1. And then I'm going to multiply that by 1,000. I'm going to get approximately 1992.2. And that's section 12.2 on geometric sequences and series.